The Cherenkov Telescope Array, named CTA, is an ESFRI initiative to build the world's largest and most sensitive ground-based high-energy gamma-ray observatory. The CTA data and their scientific products need to be preserved in a dedicated archive guaranteed to provide open and widespread access to heterogeneous scientific communities. One of the major technological challenges related to the data handling and archiving of such a huge amount of data. This demo is a first prototype of the CTA Archive using technologies developed within the INDIGO-DataCloud project. In particular, we are focusing on employing OneData solutions for developing a distributed system deployed as a federation of different storage entities. These storage entities can be included in the logical data grid topology infrastructure as the one used for production of LHC experiments. In the CTA virtual organization, simulations and CTA data reduction will redirect the output to the distributed archive. The demo infrastructure has been set up using VirtualBox virtual machines, with CentOS 7, and Docker containers for OneData services. This test infrastructure includes a CTA OneZone service, 2 OneProvider services, named CTA and Rome, and 1 client instances. This is the CTA OneZone where you can sign in using one of your existing accounts. You can create a new space from the data space management area. Next thing you need is to get support for USpace from one or more providers. For this you will have to send your token to the provider administrators. A space is a virtual directory, which contents are stored in distributed storage resources provisioned by storage providers. It is possible to add new folders or upload datasets. In this demo we upload a dataset coming from the ESFRI project which is aimed at building a first prototype of small-sized Cherenkov telescope. The data will be distributed in the 2 providers. In this case the file has been uploaded in the CTA provider which by now holds all the blocks of the file, and the metadata are also shared in the Rome provider holding no data blocks. Spaces can be shared with other users from the Spaces page. On the space, click the Settings button and pick Invite User from the drop-down menu. Copy the token and send it to the user you wish to share your space with. After receiving the token, the user can join the space. Navigate to the Spaces page, click on the Join button and paste the received token. The new space will be immediately visible on the Manage Spaces page. The ingested data need to be enriched with metadata. For this purpose, the operations are performed via the Cloud Data Management Interface, named CDMI. A client token is needed for performing the CDMI calls and we exported it as environment variable. It is possible to read the metadata with the call shown in the bash script. These are the embedded metadata we can get. We can also write extended metadata to the file such as the origin ID or the observation ID. The database managing the metadata is Couchbase, which is embedded in OneData. It contains a schemaless description of the data and is suitable to query and retrieve data from the available OneData interfaces. Once the data is stored with OneData, it could be possible to search and query the database using elastic search engines such as the N1QL or Common MapReduce functions using the standard Couchbase console and SDK from the client side. This will enable versatile access to the whole CTA dataset to higher-level application frameworks and end-users analysis tools. Furthermore, we can upload or download a file using OneData interfaces based on curl calls. This is an example on how to download the file. Finally, we show how to connect using one client and the client token. The client is started as a Docker container and it is able to mount the user spaces into the local file system at the Mount One client path. Here we see how to attach the client container and navigate through the user spaces. Thank you for watching. For any questions or comments, feel free to contact us.